Alright guys, welcome to this page of the notes. We're just going to continue with this theme of solving quadratics by graphing them. And again, at this point, you should be hopefully very comfortable with doing this. So please feel free, as always, to go ahead and work ahead of me and then just come back and check your answers. Make sure that you get what I get. And if not, you just check your answer against mine, see where you made your mistake. A great way to learn how to do these problems. As far as we go, though, we're just going to jump right into this then. It is already, actually, as far as standard form goes, remember, the A, the B, and the C have to be integers. And this one, I have not given you an equation. I've given you a function, right? So this is perfectly okay. It is in standard form. So we're all set to go ahead and find my axis of symmetry. X is going to be equal to a negative B over 2A. Let's see, my B is a minus 4. Negative times negative 4 would be a positive 4. My A is a positive 1, which means I'd have 2. So I wind up with 4 divided by 2, which is going to be a positive 2. Go ahead and set up your XY table. 2 is going to go in the middle of my table, and we'll just go in either direction from there. 1, 0, negative 1, negative 2, negative 3. Let's see, how far did I go? Negative 4. Actually, I need a little bit more space. I actually went to a minus 5. So let me go ahead and do that. Find a little bit more space here. I'll just have to write a little smaller. X, Y. All right, again, right here in the middle is going to be my 2, and then it'll be 1, 0, minus 1, minus 2, minus 3, minus 4, minus 5. And then in the other direction, we'll go to 6. So 2, 3, 4, 5, and 6. Okay, let's see here. So I plug in. Yeah, awesome. Here we go. If I plug in a positive 2, here's what we're going to wind up with. I plug 2 in for my values of x, and what we wind up with is 2 squared would be 4. 2 times a negative 4 would be a negative 8, plus 5, and I wind up getting a positive 1. That is going to be my vertex. I actually didn't go to a negative 5. It looks like I stopped at minus 3, so we can get rid of those ones. I think this half is going to be easier to do than this half. So let's go ahead and do these ones. If I plug in a positive 1, 1 squared is 1. 1 times negative 4 would be a minus 4, which would leave me with a minus 3. Plus 5 should be a minus 2 should be a positive 2. 2 and 2. Plug in 0, I should get 5 and 5. Plug in a negative 1, I wind up with 10. Oh, and that's as far as I can go because I'm already at 10, and that's as far as my graph goes. So actually, I can get rid of those ones. I can get rid of that one. All right, let's see here. What else am I looking for? Oh, that's right. Yep, check this out. Anytime x is 0, I know that that is going to be my y-intercept. Fascinating. Please notice that nowhere in the y column do I have a 0. What that means is I don't cross the x-axis. So what you guys have, if we go ahead and graph this guy, 2, 1, 3, 2, 3, 2, and 1, 2, 5, 1, 2, 3, 4, 5. There's my y-intercept, and 4, 5, and then negative 1, 10. And 5, 10. Yeah, exactly what we would have expected from my table. Right, my table doesn't have any zeros in the y column, which tells me I don't have any x-intercepts. which is exactly what we see when we graph it. My parabola is opening up. My vertex is above the x-axis, and so I actually don't have any zeros. I don't have any roots. I don't have any x-intercepts. Let's go ahead and draw that axis of symmetry in there, though. So if I draw my axis of symmetry, it would be right here. If I asked you for the roots, you would just simply tell me there are no real roots. Again, a little bit later on, I already mentioned that this means that we have imaginary solutions, and we'll get to that in section 4. But for now, you have no real roots. If I asked you for the vertex, 2, 1. If I asked you for the y-intercept, it'd be at 0, 5. I got another one for you here. Let's go ahead and try this one. Again, I need to make sure that I get this in standard form before I do anything else. That'll mean adding the 6 to the other side. So I'm going to wind up with, and actually instead of writing 0.5, I'll write 1/2. I generally like working with fractions a little better. So negative 1/2 x squared plus 1/2 x plus 6 is equal to 0. Ooh, and actually I don't really like, remember, put it in standard, to put it into standard form. I'm going to want to multiply all of these guys by that base of 2, or by the denominator of 2, to get my a, my b, and my c to be integers. So let's go ahead and do that as well. Multiply everybody by 2, and that's going to give me a minus x squared plus x plus 12 is equal to 0. All right, let's go ahead and graph this guy and see what we get. I need to set up an xy table, so what we're going to do is find my axis of symmetry. Okay, well, my b is a positive 1, my x is a negative 1, and so what I wind up with is a negative 1 divided by a negative 2, which actually should come out to be a positive 1/2. Okay, I'm going to start my xy table then with x equals a positive 1/2. I apologize, I know I'm kind of cramped for space there, but this is the one where I'm actually going to go all the way to negative 5. So I want to make sure I've got plenty of space here. We're starting at 1/2. And remember, just because this is a fraction doesn't mean the rest of them need to be fractions. I'm going to go with whole numbers on either side of 1/2, right? So the whole number below 1/2 would be 0. The whole number above 1/2 would be 1. And that's what we'll do. So we'll do 0, negative 1, negative 2, negative 3, negative 4, negative 5. And then 1, 2, 3, 4, 5, and 6 should get me all of the points I need. Let me fix my 3. All right, awesome. Here we go. Let's jump right into this. I plug a 1/2 in for all of my values of x. Again, please feel free to use a calculator. Don't fat finger something on your calculator, and you should wind up with, I get a positive 6. 6.125. Now I know that that's not really that nice a number, but that's okay. It still represents my vertex. And you don't have to graph it exactly. We'll get as close as we can. I think this half of the table is going to be easier to plug in than this half of the table. So let's go ahead and do that. If I plug in zeros, 0 and 0, that leaves me with a positive 12. Leaves me with a positive 12. . Hang on, something went, that's not right because I need, sorry, okay. What we need to do in order to find my quadratic values, to find the axis of symmetry, I put my quadratic into standard form to pull out my A and my B for finding my axis of symmetry, which we did right here. This was my axis of symmetry. Sorry, what we need to do, now that I've chosen values of x, to plug back into my function, I've got to go back to my original quadratic equation. That's this negative 1/2 x squared plus 1/2 x plus 6 is equal to 0. Plug them into there to get out my y values. All right. So when I do that, I plug a 0 in for each of these guys. That be 0, that be 0, and I'm left with positive 6. Plug in a negative 1. Again, don't fat finger something on your calculator, and you should wind up with a 5 and a 5. Plug in a negative 2. Don't fat finger something on your calculator, and you should get 3 and 3. Plug in a negative 3. Should get 0 and 0. And then I wind up with a -4 and a -9, which means I'd have -4. And then this one would also be a -9. All right, let's run through here and find out the important stuff. Again, remember, whenever x is equal to 0, that would be your y-intercept. And whenever the y is 0, I have my x-intercepts. And the other one is right down here. It looks like what I've got is a parabola that is opening down, crosses my x-axis twice. Let's go ahead and graph these. 0, 6, 1, 2, 3, 4, 5, 6 right there. I'm also going to be at 1, 6 right there. My vertex is somewhere right in between those guys. Let's see, then I'm at -2, 3, -2, 1, 2, 3. I would be at, sorry, -1, 5, not -1, 3. -1, 5. There and there. -2, 3. There we go. There and there. -3, 0. And 4, 0. -4, -4. -4, 1, 2, 3, 4. And -4. Let's see, that takes me to -5, -9, -5, -9, and 6, 9, 6, 9. And there we go. We got ourselves a parabola. Connect the dots. Feel free to throw that axis of symmetry in there as well if you would like. Oh, sorry, I missed it really bad on that side. In fact, actually, I hate that. Let me erase it and try again. I can do better. There we go. And draw that axis of symmetry in there if you would like. Again, I didn't ask you for it, but if I ever do, it's good practice to go ahead and throw your axis of symmetry in there. And again, remember the things I'm going to ask you for. I'm going to ask you for the roots, which you have 2 of, -3, 0, and 4, 0. I'll ask you for the vertex, which is at 1/2 and 6.125, and the y-intercept, which is at 0, 6. 0, 6. And again, all of that information comes right off of the table. Again, guys, what we looked at here in these last couple of problems are those 3 options you have for solutions to quadratics. You can either have one real solution where the vertex is on the x-axis. You have 2 real solutions like we do here, where you cross the x-axis twice, or you could have no real solutions where your parabola does not cross the x-axis, in which case you'd actually have imaginary solutions, which we'll get to later. Had a lot of fun doing these problems. Head on over to the next page of the notes and we'll take a look at a couple of more. I'll meet you guys there.